We're recording now. Yay. So let's start off with two different distributing problems. I don't think we need to spend too much time on the distributive property. You guys did this last year, but I'll try to come up with two that I think might be reasonably tricky. So I'll read these out loud as I'm writing them, but I'm also going to hold them up, so don't worry about asking me to repeat stuff. I'll show them to you. Okay, so first one we're going to do 2 parentheses 3x minus 2 close parentheses minus 3 times parentheses 4 minus 2x. Okay, and I'm going to put a second one on here right away. We're going to do 8x minus 16y plus 20z all over 4. Okay, so I have two problems on here. I will hold both of these up, no worries. Don't have to be copying just from my voice. And here we go. Okay, so again, two different problems involving the distributive property. These are two of the, I don't know, probably about the hardest stuff I can put on this test in terms of just distributing and combining like terms. So first one, 2 times 3x minus 2 minus 3 times 4 minus 2x. And then the second problem is 8x minus 16y plus 20z all over 4. Okay, so take a minute, try these problems. I'll try to stall a little bit if I can to give you some time to work on some things. Okay, again, I'm going to quickly go through what's on your test again because I didn't record that initially. So again, it's 9 problems on the distributive property with combining like terms, 6 problems where you have to factor out the greatest common factor, 20 equation solves that can involve ones with variables on the same side, variables on both sides, no solution and identity are possible answers, and I've also got literal equations in there, the ones with multiple variables. And then after that, there's one word problem, and Amal actually asked a good question. She asked, how many sub-questions does it have? It's a A, B, C, and D. So you're going to have to, but the subparts, I can kind of basically tell you what they are. Like the first subpart is write an expression for this, or write an equation for this person and solve it. The second one is write an equation for this person and solve it. And then the other two parts ask you to combine those two parts together. So I basically have you do two little things individually. So work with this person who's doing something individually, work with this person who's doing something individually, and then 2 parts where you put them together. Okay? Hopefully, I was able to stall enough time for you. So I will show my work on the first one. I'm not going to rewrite the problem. It was on a separate sheet of paper. I don't know where I had a little mini dry erase board. I don't know where that went. I need a new one. So the first one, you distribute the 2 and you get 6x minus 4. And then the key is you distribute a negative 3 and you should get minus 12 plus 6x. Okay, so that's what I get after I'm done distributing. The signs are very, very important there. And then I combine my like terms. 6x plus 6x is 12. X and negative 4 and negative 12 make negative 16. So there's what you should have had for the first one, 12x minus 16, or negative 16 plus 12x if you didn't feel like putting the x term first. Okay, and then the second one, you're just dividing all the coefficients by 4, so you get you should get 2x minus 4y plus 20z. Or plus 20z, silly me, plus 5z. I didn't actually do the division there. That would have been helpful. Okay, so there's what you should get for the other distributive property one. Cool. Okay, greatest common factor. Woohoo. Okay, so I'm going to give you 2, and I'm going to ask you to factor out the greatest common factor. Okay, so you're undoing the distributive property, basically. Okay, so factor out the greatest common factor. Let's give you 10xy minus 5yz plus 15xz. And let's give you, and let's give you 8x squared y cubed plus 12x cubed y squared. Okay, so for both of these, I would love it if you would factor out the greatest common factor. I will hold that up so you can see it. There we go. There we go. Boom. Okay, so it's factor out the greatest common factor for both of those. Factor out the greatest common factor for both of those. Okay, even if you have a question on the last one, write it down. Write this problem down. Okay. Giving you a few extra seconds to write this one down. Amal had a question on the last one, and it's a very, very good question. Okay. Her question was, should we simplify 12x? It's very hard to point in like a mirror. I'm just going to kind of look. Should we simplify this to 3x minus 4? The answer is no. The answer is no because you can't. That is bad math. We can't do that. We can't just divide two things by 4 when there's not an equation. The reason you're often allowed to divide everything by 4 is, for example, I'll add this in green. If we had equals 8, that's a terrible 8. If we had equals 8, we could divide everything by 4 because what we would be doing is we would be changing both sides, every term in there, but since it was on both sides of the equation would still be balanced, and that's all we care about in an equation. When you're simplifying an expression, what you have to understand is 12x minus 16 represents a number, right? Depending on what x is, it represents a very specific number. Okay, so if we just divide both terms by 4, we're changing what that number is by dividing by 4 twice. So you cannot just divide an expression by 4. You can do that on both sides of an equation, not in an expression. You can also divide the numerator and denominator of a fraction by 4, but that's just part of reducing a fraction. Okay, you cannot do that with an expression. Okay, that was a very good question though, and it is a very common mistake that I see. So that was a great one. Okay, factoring out the GCF in both of these. My GCF in the first one is 5. They don't all have an X or a Y or a Z. They've got 2 of them, but none of them all have an X or all have a Y or all have a Z. So it's just 5. Pull the 5 outside parentheses and undo the distributive property by dividing everything by 5. And we get 5 times parentheses 2xy minus yz plus 3xz. That's it for the first one. That's all we can do. Second one, the GCF of 8 and 12 is 4, and they both have at least 2 x's and 2 y's. So that means I can pull out an x squared and a y squared. Okay, and that'll leave us with 2y and 3x. And that's it. Okay, once we pull out 2 x's and 2 y's, we've only got 1 y left in the first term and 1 x left in the second term, and whoops, there we go. That is the answer that we get right there. 4x squared y squared times parentheses 2y plus 3x. Okay, I mean, those are probably 2 of the more challenging ones that you could have in a factor out the greatest common factor section. We are cruising right along. We are into the solve section. It's hard for me to tell how many of these I should give you right now. It is by far the biggest section on your test, but I mean, some of them are fairly straightforward ones that you've been doing for a long time. The biggest things to remember are the identities, the no solutions, when do we get that, when do we not get that, and all that kind of stuff. So I'm going to give you 3 right off the bat, okay? And yeah, I'm not going to give you any literal equations just yet. So the first one, again, I will read these out loud mostly because I don't like sitting here awkwardly in silence because there's no one else home, so it would just be really quiet. So I'll read these out loud, and if you can copy down as fast as I can talk and write at the same time, then great. If not, I'm going to hold them up anyway. For the first one, let's go 3 parentheses 2x minus 1 equals 5x, and let's go with, sorry, doing quick math in my head, 5x minus 8 I think would be most excellent. So we're going to do that one first, and then we're going to go with second one is going to be 3 minus 2 parentheses 3x minus 1 equals negative 6x plus 4. And then for one more final one, let's go with 2x minus 1 equals 2 parentheses x plus 3 close parentheses minus 7. Let's go with that. Okay, these are really hard to make up off the top of my head, but I kind of gave you ones very similar to ones you'd have on the test. So I'm going to hold those up now because I know you probably got almost nothing down. Okay, so here's your 3 equations, 3 separate equations. I'll give you some time to copy that down. We are up to 6 viewers, ladies and gentlemen, 6 viewers, which really isn't bad. If you figure that we've only got somewhere around 40 people in honors, and it's probably more important for those that have the test tomorrow to be here right now. That's not too bad, and I know a lot of ladies have field hockey that goes late and stuff like that, so glad there's 6 of you here. I don't know who else is here besides Amal, because she's the only one that said anything, but hopefully you guys are doing okay. All right, I think I've given you enough time to copy these down. Now it's just copying, so hopefully you got them down. If not, I'm sure you'll let me know in the chat window, and I'll panic because you aren't seeing this until 20 seconds after I've said it. We can take a look around my room. This is very much a man room. It is really just a Bulls room. I have lots of Bulls jerseys up. I've got a Bulls hat hanging there. I do have a random Bears jersey in there that I don't really wear. Boo Bears, yeah, I know. But I've got that Bulls logo in the corner. Be impressed. My wife painted that by hand. Like we were using a projector as like as kind of a little bit of a help there, but I feel like it looks pretty darn good, really. I don't know. I thought so anyway, so I thought that looked pretty good. So it's my Bulls themed room. I feel like this is something every guy needs when they grow up, is they need like a sports or video game or some kind of themed room that can just be theirs. So I like it. It's wonderful. So hopefully I've stalled enough time for you guys to get through these. I mean, I know they're annoying to write, but figuring they probably shouldn't be too bad to solve. Okay, so the first one, I distribute, and I get 6x minus 3 equals 5x minus 8. Okay, I get that. Then I subtract 5x from both sides, and I get x minus 3 equals negative 8. Okay, so I subtracted 5x from both sides, and then I add 3, and I get x equals negative 5. Okay, that's pretty much it there. Nothing too challenging. Okay, a lot of people get freaked out with the 6x and 5x or 4x and 3x, and I don't know. Oftentimes, like if I had made this one equal to 0, I think I could have gotten a lot of people to pick no solution, but x can be 0, guys. Just please don't forget that. It's really important. Okay, the next one, I'll switch over to green for this one so I can hopefully squeeze it onto this piece of paper. So I'm going to distribute on the left side, and I'm distributing a negative 2 over there. Okay, so it should be 3 minus 6x plus 2 equals negative 6x plus 4. Okay, that's what I get after I distribute. Add your like terms. Okay, so I get negative 6x plus 5 equals negative 6x plus 4. Many of you probably already know what the answer is, but just in case you miss it, it's a good practice to get all of your variables on the same side. So I'll add 6x to both sides. And when I do that, I get 5 equals 4. Since 5 equals 4 is nonsense and is very, very bad. That would be really weird if that were the case. This one is no solution. Okay. And you could start plugging in a bunch of numbers and you'd find that they were always the same like distance apart, which is kind of cool, I think. And then the last one, I'm going to distribute the 2 on the right side this time. I've got 2x minus 1 on the left equals, distribute the 2x plus 6 minus 7. Surprise, surprise, we get 2x minus 1 equals 2x minus 1. And that one is an identity. Excuse me. An identity means you could plug in any number and you should get the same thing on both sides. So you could feel free to try it out. That'd be a great way to check those identity answers. No solutions are tough to check, because if it was the difference between a no solution and a one solution problem, it'd be really hard to tell. But an identity is easy to check. Go to the original equation, and you should be able to plug in any number and it should work out just fine. Okay, I'm not saying those were the hardest problems on there, but identity and no solution are ones to watch out for. I'm going to give you guys a couple literal equations now, because I'm just going to go out on a limb and say those are not fun. Okay, I think you guys really do make them a little bit harder than they need to be sometimes. You overthink it a little bit. Try to work your way back to, hey, this is just the same thing as it would be with numbers, except I'm not going to be able to do as much combining like terms and stuff like that. Okay, so we're going to do negative 2x minus 12y plus 6x equals 8. And which ones always cause problems? Let's go with, this is a super fun one. Let's go with a over x equals a over, no, that's not right. I'm going to change my mind. Scratch out that last problem I was describing. Let's go with ab over x equals a over b. There we go. That's what I wanted to do. Sorry about that one. And one more just for, gosh, we've just done so many like that one. I'll give you one more. Let's go with 0.5 abx equals 4b. Okay, I will hold up all of those problems for you. Okay, so there's your problems. Negative 2x minus 12y plus 6x equals 8. AB over x equals a over b. And, sorry about that, 0.5 abx equals 4b. Those are your 3 literal equations problems that I think are a good representation. Amal asked, are we allowed to ask questions during the test? Yes. Whether or not I can answer them is a different story. Okay, most of the time my general rule is if you're asking me how to do something, there is probably close to 0 chance that I'm going to be able to give you anything. Okay, but if you're just asking for a clarification, like especially in a word problem, because I write my own word problems and I'm not perfect, so sometimes maybe my wording's not perfect. If I think the wording's good enough, and it's perfect and you should be able to get it, I might tell you that, but most of the time I try to answer your question, like if you have a question on directions or fractions or decimals, okay, all that kind of stuff, like you can ask, no harm in asking. Many times I'll just tell you there's no way I can tell you that, yeah, you can definitely ask questions. And Amal asked for the last one, can we multiply everything by 10 and then solve the problem to get rid of decimals? Yes, guys, when you have equations, you may always multiply both sides of an equation by a constant. You can multiply both sides of that equation by 2,000 if you felt like it. Doesn't matter. Okay. So yeah, for any of the decimal ones, if you just want to get rid of the decimals because you don't like them for whatever reason, multiply everything by 10. Or if it was like a 0.25 or a 0.15 or something like that, maybe you multiply everything by 100. Yeah, you can absolutely multiply both sides of an equation by a constant. That is 100% absolutely always okay, as long as you're doing it to both sides of an equation, not two terms in an expression. If there's no equal sign, that's when you really got to be careful. Okay. All right. Hopefully you've had enough time. These are problems that if you don't get them, it's giving you more time is not going to help you riddle it out, really. I mean, you either remember how to do these or you don't. And I think my personal opinion is the second one is the hardest because I don't know that I've given you any with x in the denominator yet. But you should really know how to do it. But I felt like giving you something hard, so we'll see how it goes. First one, combine your like terms. And when you combine negative 2x and 6x, you get 4x. So we get 4x minus 12y equals 8. What you do after this point is up to you. A lot of people will divide everything by 4. I like to go the standard way and just add 12y to both sides. I don't know why and I'm actually going to write out my steps here just because I know it helps to see the steps here because it's not as numerical. There's a lot more variables involved. Okay, and then divide everything by 4. And we should get x equals 2 plus 3y. And yes, this should be your answer. I can't think of, aside from maybe 3y plus x equals 3y plus 2, if you felt like reordering, there's really nothing else that should be your answer here. Okay, the next one. AB over x equals a over b. You have so many choices to do this, it is almost overwhelming. So one thing you need to realize is that if you need to get that x up into a numerator, because otherwise the best you can do is solve for 1 over x. So you need to get that x in your numerator. So I'm actually going to multiply both sides by x, which is unusual. We don't typically do that, but I'm going to do it. Okay, and I get AB equals ax over b. Now this probably looks a lot more familiar. I'm going to multiply everything by b to get rid of the b. And I get ab squared equals ax. And then I'm going to divide everything by a. And I get x equals b squared. Woo! There's another way that you could do this too, and I'm going to go ahead and show you the other way. Simple question. We know that 1/3 is equal to 2 over 6, right? Duh. Okay, we know that. What if I flip both fractions? Take the reciprocal of both fractions. Is 3 over 1 equal to 6 over 2? The answer is yes. So if you get stuck with an x in a place you don't want it to be, sometimes we have to deal with it being in the denominator, and there's very, very easy ways to deal with it. But one thing that you could have done here is you could have flipped the whole problem around. You could have changed this to x over ab equals b over a. So I flipped both fractions. It's still the same problem. Sorry, there's a little squiggly there. It's not supposed to be there. So x over ab equals b over a. I could do that. No problem. Now I just multiply both sides by ab, by a and b, and the a's will cancel and the b's are squared because there's 2 of them. So I get x equals b squared. That's fine to do. Okay, that's, again, it's a special case. You have a fraction equal to a fraction. So the same things you could do with numbers in there you could do here. So hopefully everybody got that one. That was probably the toughest one. The last one, you know what? I'm going to go the Amal method. Okay? She said multiply everything by 10 to get rid of the decimals. Fine. I get 5abx equals 40 b. Okay. 5abx equals 40b. Divide by, I'm going to do it all at once. Divide by 5ab. Cancel your b's. 40 divided by 5 is 8. And I get x equals 8 over a. The key is it's over a. X equals 8 over a. Cool? Cool. All right, I'm all asked if I could do that over again. Again, I warned you guys about this in class. I don't necessarily know what you're talking about. I'm going to go out on a limb and say you were talking about the one about ratios. Okay? Okay. AB over X equals A over B. There's so many ways you could do this one. Okay, you just got to utilize your fraction skills a little bit, or your proportion skills. This is a proportion. Okay, so my suggestion, again, is get your x out of the denominator. You can't solve for an x when it's in the denominator because then it's really the same thing as 1 over x. Okay, so what I would do is I would multiply both sides by x. That gives me AB equals AX over B. Okay, so that's my first step. Multiply both sides by x. Okay? Now, I'm going to switch. You know what I'm going to do just to make life easier? I'm going to switch these around. I'm going to flip that around my equal sign so it looks a little more normal to you. Okay? You can flip things around an equal sign. That's just fine because they're still equal. It's like saying, I can't even, that's like saying my age is equal to 29. 29 is equal to my age. You're saying it in a different way, but it's still the same thing. Okay, so now it should look pretty straightforward. You got to multiply by b to get rid of the b. Ax equals ab squared, and then divide by a. And you get x equals b squared. It's a tough problem. It's a tough problem. I respect that, but get that x out. You can't solve for an x in a denominator. That's about the trickiest one I could give you as far as literal equations go. Okay, time is running low for me because I still have some dinner to cook, and my wife will be home probably in about 15 minutes or so. So here's what we're going to do. We're going to do one word problem, and I'll give you I'm going to give you, one nice solid problem. So let's see. I'm going to go with, we're going to have two people. One of them is saving money and one of them is losing money. So, oh yeah, and guys, I'm sorry about the commercials. There's not a lot I can do with that. I'm not sure if the ad block extension for Chrome helps out with that or not. Sorry. If you miss anything, I am posting to YouTube afterwards. If you're watching this on YouTube, you already know that. Okay, I'm going to do one word problem with some people. One person saving money and one person losing. Okay, so I'm going to say my wife, she starts off with $20. $20, and she is saving $5 a week. Okay, and I start off with let's go with $150, Mr. Moneybags, and I am spending. Let's go with $10 a week. Very, very spendy. Okay, very, very spendy. First thing I want you to do. Okay, my wife, $20, saves $5 a week. I start off with 100. That's 150. Ooh, that blended in with the dollar sign. $150. and I'm spending $10 a week. Okay? First thing I want you to do is define a variable and then write an expression that represents how much money my wife has after a certain amount of time and how much money I have after a certain amount of time. Write expressions that represent the amount of money each of us have left after a certain amount of time. Okay? I will stall for a few seconds here. Just kind of sit here and stare blankly at the screen. Yeah, because I don't really have any additional information for you. And we don't have too many questions tonight, which is probably a good sign. Okay, hopefully you chose a variable x or whatever you want, t for time, whatever, to represent the number of weeks that have passed. My wife's expression, so I mean, the way that I come up with expressions to represent something is I just ask myself, well, how would I figure out how much money my wife had after 2 weeks? Well, I'd take 5 times 2, which is 10, and then I'd add that to 20. Well, 3 weeks. I'd take 5 times 3, that's 15, and I'd add that to 20. Okay, so basically I'm taking 5 times x, whatever the number of weeks is, and I'm adding that to 20. For me, I'm taking 150 and I'm subtracting the $10 times the number of weeks. Woo! Okay, so there's the two expressions. And you don't need the multiplication symbol in there. As I was talking, I said multiplication, so I put a little dot. So 20 plus 5x and 150 minus 10x. I could ask you to do all sorts of things. I could say my wife is saving up for I don't know what my wife wants. She's saving up for some new shoes, a couple pairs of new shoes. No, some really nice walking shoes. Yeah, she likes, she does spend money on good shoes if she's going to wear them every day and walk in them a lot. So maybe she wants to spend, let's say, $100 on that. That'd be a lot for a pair of shoes, I think, but I'm sure many of the girls will disagree with me. So I could ask you, how long until she has $100? Well, let's do that. How long until my wife has $100? Tell me that. Just how long until my wife has $100? Figure it out. And no fat cats tonight. They're downstairs, and I tried carrying one of them up here to see if he would just come up. Like, figured he can't make too much of a mess. But yeah, I really, no. He was getting upset. Like, as soon as I took him up the stairs, he was like freaking out. Like, I'm not supposed to be here. He was going crazy. So we're not going to do that. All right. So if we wanted to know how long until my wife had $100, this is really easy. We don't involve my expression at all. We would just take 20 plus 5x, set it equal to 100, and solve. When I do that, I subtract 20. I get 5x equals 80. X equals 16. So in 16 weeks, my wife would have $100. If I wanted to know how much money I had after a certain amount of time, I could just plug in a number for X, but let's do the obvious thing. I started off with a lot more money and was losing it. She started off with less money and was saving it. Let's find out, when did we have the same amount of money? Okay, when did we have the same amount of money? Take a few seconds, figure that out. Shouldn't be all that bad. If you get a decimal, you can decide what you want to do with that. Decide what you want to do with that decimal. I'm going to let you see if you can figure it out. I'll kind of tell you what I would think to do with that decimal in this particular situation, but yeah, I'll let you figure that out for right now. It's funny because Amal just actually asked, are you going to do that question, which is, in how long will they both have the same money? And it's funny because I already asked it. She just doesn't know it yet. And she's going to be like, oh, yes, look at that. Okay. Hopefully you've already had enough time to do this. So same amount of money, pretty simple. 20 plus 5x equals 150 minus 10x. If you want to know when they're the same, use the mathematical symbol for same and plop an equal sign in front of them. Okay? Solve for x. I'm going to add 10x to both sides. And I get 20 plus 15x equals 150. Then I subtract 20 and I get 15x equals 130. Divide by 15. And here's where life gets interesting. So if I divide this on a calculator, it's not going to give me a whole number answer. It's going to give me a decimal answer. It's going to give me like 8 2/3 or 8.6 repeating if you do this on a calculator. So you kind of have to ask yourself, what do you do with that decimal? What makes sense? It depends. I think you could put a couple different things for that answer and it would make sense. Now, you need to show the work to get there. But you could argue that they never meet because my wife is saving $5 a week. So if you just assume she's putting $5 in a jar every Friday evening, and you assume that I am, I don't know, going out and getting $10 worth of ice cream, exactly $10 worth of ice cream every Friday, we would never meet because we don't meet at a whole number of weeks, so we can't meet in the middle of the week. Now, if you assume that she's saving a portion amount of that money every day and I'm spending a portion amount of money every day, you could just say, well, they meet at 8 2/3 weeks. Okay, or you could try to convert 2/3 of a week to a day. It'd be like somewhere between the 4th and 5th day of the 8th week. It's kind of up to you what you do with that information, but that's why in a word problem, after you do that, you should give an answer and then make sure that it's, or you could just say they meet at 8 2/3 weeks if you want to leave it at that. But if you're going to put something on there like they never meet, you should probably substantiate that with, I'm assuming that all the money stuff happens at the end of the week, I would think. I don't know. And I'm not too picky about that stuff, but it's really important for you to start kind of thinking in that way. And I think that would be helpful. Okay. That's all I've got for you guys. I think this is a good representation of what is going to be on your test. If you missed something, I'm going to post this to YouTube. It should be up. Guys, it really depends on how fast YouTube is. I mean, literally, I'm going to stop recording, and I'm going to stop recording and then try to upload it to YouTube. It just depends on how fast YouTube goes. So I'll get it up as quick as I can. One last question at the end. Amal said, can't you just say 8 weeks? No, because they definitely did not meet at 8 weeks. Okay? After 8 weeks, I'd be down $80 and I'd be at 70. After 8 weeks, my wife would be up $40 and she would be at 60. So you could say they meet in the middle of the 8th week. That would be fine. But you either need to say you either need to leave the decimal answer, you need to say they don't meet and kind of explain why, or you need to basically just say they meet sometime in the middle of the 8th week. But again, you can just leave it as 8 2/3 weeks and kind of assume that they meet sometime in the middle of that week, and that's just fine. Okay, that's it for this. I'll upload this to YouTube, and hopefully that'll be helpful. I'll be around sometime tomorrow morning for any last-minute questions you have, but I'm assuming this test is going to go pretty well for you guys. So good luck in your studies tonight, and have a good night.